The interstellar object known as 3I/Atlas has captured the imagination of scientists, astronomers, and curious observers across the world, especially as it approaches its closest point to the Sun on October 29, 2025. This moment, known as perihelion, places the object approximately 203 million kilometers from the Sun, a distance that, while still vast, is close enough for solar radiation and gravitational forces to exert significant influence on its structure and trajectory. For most natural comets, this phase is simply one more step in their long, cold journey through space, resulting in ordinary processes such as heating, outgassing, and the brightening of a tail. However, 3I/Atlas is not viewed as an ordinary comet by many, since it has traveled from interstellar space. Beyond our Sun's gravitational influence, it naturally carries with it an air of mystery. Objects entering from outside the solar system are rare, with only a handful ever observed, and each one raises captivating questions about where it came from, how it formed, and what it might reveal about distant planetary systems. The intrigue surrounding 3I/Atlas has intensified due to its current invisibility. As it travels behind the Sun from our vantage point on Earth, we cannot observe this crucial period when the object approaches perihelion. This lack of observational access has given rise to speculation, prompting some scientists to wonder whether the perfectly timed solar encounter is merely a cosmic coincidence, or if it could be something more deliberate. In interstellar space, a spacecraft or artificial probe could, in theory, use a star's gravity for slingshot maneuvers, altering its direction or accelerating without expending fuel. If 3I/Atlas were artificial in origin, perihelion would be the most efficient and powerful moment to execute such maneuvers. The inability to observe this stage only deepens the sense of mystery, leaving a gap that speculation readily fills. Some researchers, including the well-known astrophysicist Avi Loeb, have drawn parallels between the object and the Trojan horse from ancient Greek mythology. The Trojan horse appeared to be a harmless gift, but it concealed a dangerous secret within. By analogy, 3I/Atlas could be disguised as a typical comet, yet potentially harbor technological features or artificial mechanisms hidden beneath its outward appearance. Loeb's comparisons are not meant to incite fear, but to encourage scientific curiosity and to push for open-minded investigation. Interstellar objects are inherently strange by nature, and some of them, like the famous 1I/Oumuamua, displayed unusual properties that could not be fully explained by normal cometary models. So when an object like 3I/Atlas exhibits unusual behavior, scientists are compelled to consider all possible explanations, both natural and artificial. The timing of the event, with perihelion occurring just days before Halloween, adds an almost poetic or symbolic layer to the discussion. This season of costumes, disguises, and hidden identities has given rise to playful speculation that 3I/Atlas might be wearing a costume, presenting itself as a comet while concealing something beneath the surface. While this analogy is used largely for dramatic effect, it resonates with people because of the genuine mysteries surrounding the object's composition and behavior. Observations made earlier in the year suggested that 3I/Atlas possesses an unusually high nickel content, far higher than what is seen in typical comets. Nickel-rich bodies are often associated with metallic asteroids or fragments of planetary cores, suggesting a violent or unusual origin. In natural scenarios, such high metal content is rare for an icy interstellar traveler. This is one reason the object's structure has drawn attention and seems inconsistent with the characteristics expected from a simple comet formed in the cold outskirts of a solar system. Another puzzling aspect is 3I/Atlas's trajectory. Observations have shown it to be unusually stable, showing less of the random wobbling or drift that can occur when a comet outgasses asymmetrically. Stability alone does not prove artificiality, but when combined with other odd traits, it becomes part of a larger pattern that researchers cannot ignore. An especially strange feature was the emergence of a second tail that pointed in the opposite direction of the object's motion. Typical comets have two tails, a dust tail and an ion tail, but both point generally away from the sun due to solar radiation and the solar wind. A tail that forms ahead of the direction of travel is exceptionally unusual. There are natural explanations for some odd tail behaviors, such as solar magnetic influences or fragmenting debris. But the exact configuration observed in 3I/Atlas did not neatly match known physical models. For some scientists, such anomalies hint at the possibility of active maneuvering or artificial processes, though others caution that nature is full of surprises and that not all unusual observations must point to technology. Regardless of the object's origin, perihelion will act as a natural stress test. If 3I/Atlas is a brittle, loosely bound comet, essentially a fluffy cluster of ice, dust, and rock held together by weak gravitational forces, the extreme heating from solar radiation could cause it to fragment or even disintegrate entirely. At 203 million kilometers from the Sun, the object will experience an estimated solar flux of about 770 W/m superscript 2. This level of radiation is strong enough to significantly heat its surface, causing ices to sublimate explosively and potentially triggering internal structural collapse. If the body splits apart, the smaller pieces will evaporate even more rapidly due to their increased surface area to mass ratio, releasing huge plumes of gas and dust. Such fragmentation would be a dramatic but natural fate, producing a glowing trail that astronomers could observe once the object re-emerges from behind the sun. Many comets from our own solar system have suffered similar fates when approaching too close to the sun. On the other hand, if 3I/Atlas does not fragment, and if it displays behavior inconsistent with natural outgassing, such as changing direction without a clear physical cause, this would raise far more questions. An artificial craft could theoretically use heat gathered near the sun to power engines, activate shielding mechanisms, or deploy miniature probes designed to explore planetary systems quietly. Mini probes could scatter outward, small enough to avoid detection by Earth's telescopes, yet capable of gathering data or performing reconnaissance. These ideas lie more in the realm of speculation than established science, but they are not impossible. Humanity itself has launched spacecraft that perform solar-assisted maneuvers and deploy smaller instruments during flybys. From a technological perspective, the concept is plausible, though there is no concrete evidence yet to support this scenario for 3I/Atlas. If an artificial object were truly operating near perihelion, it might radiate excess heat from internal engines or power systems. It could even emit artificial lighting, reflections, or spectral signatures inconsistent with cometary material. Unfortunately, because the object is currently behind the sun, such observations cannot be made. Earth-based telescopes will not regain a view of 3I/Atlas until weeks or even months after perihelion, meaning that if any unusual activity occurs in the meantime, humanity will only see its aftermath. This anticipation contributes to the sense of suspense. People are waiting to see whether 3I/Atlas behaves like a natural comet, fragmenting, brightening, or fading away, or whether it surprises us with unexpected, perhaps unexplainable behaviors. Over the coming months, astronomers will be watching closely as the object returns to visibility. They will analyze its brightness, tail structure, rotation, and chemical emissions. Any deviation from natural expectations will be scrutinized. Some hope that the object will produce clear data revealing its true nature. Others expect that even with new observations, it will remain a puzzle, just as previous interstellar visitors have. In the end, 3I/Atlas represents more than just a physical object. It is a symbol of humanity's curiosity, a reminder that the universe is full of unknowns. Whether it is a natural wanderer or something more sophisticated, it invites us to imagine possibilities far beyond our current understanding and to embrace the spirit of exploration that drives scientific discovery forward.